In this video we're going to look at compound interest, and by the end of it you'll be able to determine the difference between compound interest and simple interest. So to begin with, we're just going to fill this table out, and this will help you identify how compound interest actually works. So to start with, we're investing $10,000 and it's going to be invested compounded, okay? Our rate is 5%, and we're going to do it for 3 years, and we want to see how much we have at the end of it. Then we'll compare it to what we would have had with simple interest. So to begin with, 0.05 times 10,000 equals $500, and our closing balance will be 10,500. So our opening balance will be that 10,500 for the year, second year. So we need to put 10,500, and our interest on that is going to be 525. Our closing balance will be $11,025. So for our third year, our closing balance from year 2 will be our opening balance, and that's what we're going to earn interest on, and that equals $551.25, and our closing balance is $11,576.25. Okay, now let's see what we get if we use the simple interest formula. Remember, I equals P R N. So the principal, 10,000, times the rate, 5%, times the number of years. The interest is $1,500. Okay, so our original investment, 10,000, plus 1,500 equals 11,500. Now, we can see that the compounded interest is $11,576.25 after the 3 years. So that's why it is better to invest your money using compound interest than it is the simple interest. And the reason that is because you earn interest on your interest each additional year. Okay, now we're going to look at an example. Okay, we want to find the value of an investment if $8,000 is invested at 5% compounded annually for 4 years. Well, first of all, I'm going to introduce you to the compound interest formula. I'm going to call it final amount equals P, which is the principal, the original money invested, 1 plus R, which is the rate, to the power of N, which is the number of terms. So our final amount is going to equal, okay, I will do, P is 8,000, and 1 plus the rate as a decimal, 0.05, and it's for 4 years, equals $9,724.05. Okay, let's look at example 2. After 6 years, the loan has grown to $62,150. If the interest was compounded annually at a rate of 9%, find the size of the initial loan to the nearest dollar. Okay, so we know that final amount equals principal, 1 plus the rate, and the number of terms. Okay, so the original amount, the final amount is $62,150. We don't know the principal. We know the rate, 0.09, and the number of terms was 6. Now, actually there is a multiplication in between the p. So what we're going to do is divide both sides by 1.09, put it in brackets, to the power of 6. 1.09 to the power of 6, and that's going to cancel that off, and we'll be left with p on its own. And we get that p equals $37,058, and that's to the nearest dollar. So the original investment was $37,058. Okay, looking at example number 3. A car worth $30,000 will depreciate by 15% per annum. What will a car be worth at the end of the 5th year? Okay, now the depreciation formula is very similar to the compound interest formula. So we have our final amount equals P, and we can call that the principal again. Now it's 1, the difference is it's minus the rate to the power of n. So compound interest is 1 plus the rate, and depreciation formula uses 1 minus the rate. Okay, I'm going to do this in blue now. So it equals the principal, $30,000. 1 minus the rate is, as a decimal, 0.15. And they want to know what it will be at the end of the 5th year, so to the power of 5. And we get that is $13,311 to the nearest dollar.